The creature in the image above may at first appear monstrous. Its ridged, armor-plated shell, cavernous jaws, and mud-caked body making it look like something resurrected from prehistory. Indeed, the alligator snapping turtle, Macrochlis teminki, has often been described as a living fossil, one of the last surviving members of a lineage that has changed little since the time of the dinosaurs. Capable of reaching weights of over 200 pounds in rare cases, these turtles are apex predators in the freshwater systems they inhabit, and they play a remarkable role in the ecological balance of rivers, swamps, and lakes. One striking feature of this reptile, as noted in the original description, is its ability to consume almost anything that crosses its path. A 50-pound specimen, already considered mature, but far from record-breaking in size, is a voracious eating machine. Its diet includes fish, amphibians, aquatic invertebrates, and even smaller turtles. With powerful jaws capable of crushing bone and shell alike, it has no difficulty dismantling prey, leaving little behind. In a confined pond, an individual can swiftly strip the waters of fish and other creatures, leaving a dramatic ecological void in its wake. This is why its presence in artificial ponds or managed waterways is often closely monitored by conservationists and biologists. Seasonal dormancy and metabolic control, yet this relentless appetite is not constant year-round. Unlike certain fish species that adapt to colder temperatures by adjusting their metabolic processes and continuing to feed even in icy waters, the alligator snapping turtle follows a different survival strategy. As autumn turns to winter and water temperatures begin to drop, this reptile gradually ceases feeding. By the time temperatures reach near freezing levels, the turtle enters a state of dormancy, conserving energy by dramatically lowering its metabolic rate. During this period, which can last several months, it does not eat at all. This seasonal adaptation highlights the turtle's evolutionary genius. While a constant supply of food is not guaranteed in every ecosystem, shutting down its digestive processes allows the turtle to survive prolonged periods without nourishment. In this respect, it resembles bears entering hibernation or certain amphibians burrowing deep into mud during dry or cold seasons. The difference lies in how the turtle manages respiration and energy at the cellular level, which brings us to one of its most fascinating physiological adaptations. A unique respiratory system. Unlike mammals, whose rib cages expand and contract to facilitate breathing, turtles face a unique challenge. Their lungs are enclosed within a rigid shell. The hard carapace and plastron, the upper and lower portions of the shell, provide excellent protection against predators. But remove the possibility of using muscular expansion of the chest cavity to draw in air. Instead, turtles rely on specialized sets of muscles attached to the limbs and the shell, which effectively squeeze air out of the lungs. When these muscles relax, the negative pressure difference allows fresh air to rush back in. For humans, breathing works in the opposite manner. Our lungs expand when the diaphragm contracts, drawing in air, and collapse when the diaphragm relaxes. The turtle has reversed mechanism, demonstrates an ingenious evolutionary workaround to the constraints imposed by its armored body plan. Even more remarkable is the turtle's ability to absorb oxygen directly from water through a specialized anatomical feature known as the cloaca. The cloaca serves multiple functions in reptiles, including excretion and reproduction. But in the alligator snapping turtle, it has developed into an auxiliary respiratory organ. Richly lined with blood vessels, the cloacal chamber can extract dissolved oxygen from surrounding water, allowing the turtle to breathe while remaining submerged. This is particularly advantageous during winter dormancy, when the turtle remains at the bottom of lakes or rivers, motionless for weeks on end. At water temperatures below 50 degrees Fahrenheit, 10 degrees Celsius, the turtle can remain underwater for days, sometimes even weeks, without surfacing. By combining lung-based breathing with cloacal respiration, it maximizes efficiency and reduces the risk of predation while minimizing energy expenditure. The role of predation and feeding behavior. The alligator snapping turtle's feeding methods are as fascinating as its respiratory adaptations. Unlike many active hunters, this turtle is primarily an ambush predator. It often buries itself in the mud at the bottom of rivers or swamps, camouflaged perfectly against debris and vegetation. Its most remarkable adaptation for hunting is the vermiform worm-shaped appendage located on its tongue. By holding its mouth wide open and wriggling this pink lure, the turtle mimics the appearance of a worm, attracting curious fish directly into its cavernous jaws. Once the prey is within striking distance, the turtle snaps its jaws shut with bone-crushing force, a motion that gives the species its name. Few fish escape once caught in this deadly trap. This passive hunting strategy allows the turtle to conserve energy, making it perfectly adapted to environments where resources may be sporadically distributed. Ecological importance. While the alligator snapping turtle may appear as a fearsome and destructive predator, it plays a critical ecological role in its habitat. By feeding on diseased or weakened fish and scavenging on carrion, it helps maintain a balanced aquatic ecosystem. Its predation prevents overpopulation of certain species, ensuring diversity in freshwater communities. Moreover, as a species with relatively slow reproduction, females lay eggs only once a year, with many hatchlings failing to survive predation. It is particularly sensitive to habitat disruption. Thus, the presence of healthy populations often indicates a thriving and balanced ecosystem. Anatomy and physical design. The alligator snapping turtle's physical appearance is as striking as its behavior. The shell is not smooth like that of many other turtle species, but is instead adorned with 3 pronounced ridges, each lined with spiky projections. This jagged, almost prehistoric design not only provides camouflage among submerged logs and roots, but also reinforces the creature's image as a living relic from an ancient world. Its thick, muscular neck and massive head add to its formidable appearance, while its beak-like jaws resemble those of birds of prey, perfectly shaped for tearing through flesh and bone. Unlike sea turtles that have evolved streamlined shells for efficient swimming across vast ocean distances, the alligator snapping turtle is built for stealth and ambush in slow-moving waters. Its heavy, rugged carapace, combined with powerful limbs tipped with claws, makes it more suited for life in murky rivers than open waters. Winter survival and adaptability. Perhaps the most fascinating aspect of this turtle's biology remains its adaptability to extreme conditions. The ability to endure long months without food by lowering its metabolic demands, coupled with cloacal respiration, demonstrates a finely tuned survival system. These adaptations reveal how evolution has crafted a creature capable of thriving in environments where seasonal changes dramatically alter resource availability. Unlike fish that remain active under icy waters, continuously seeking food, the turtle's strategy is one of endurance and patience. It withdraws into itself, slowing down every aspect of its physiology until the environment once again becomes favorable. In doing so, it ensures survival not through constant activity, but through careful conservation of energy. Human interaction and conservation, unfortunately, the very qualities that make the alligator snapping turtle unique, have also made it vulnerable to human exploitation. For centuries, these turtles were hunted for their meat, which was a prized delicacy in turtle soup. Overharvesting, combined with habitat loss due to damming, pollution, and wetland drainage, has led to severe population declines in many areas of the southeastern United States, their primary range. Conservation efforts now include legal protection in several states, breeding programs, and habitat restoration projects. Public education about the ecological importance of these creatures has also helped reduce indiscriminate killing. While still considered vulnerable, the alligator snapping turtle has become a symbol of freshwater conservation in North America, a testament to design and adaptation. Every aspect of the alligator snapping turtle's biology, from its unique respiration system in ambush, feeding strategies to its seasonal dormancy speaks of remarkable adaptation. Whether one interprets these traits through the lens of evolution or as evidence of intentional design, the result is the same. This turtle is a marvel of nature's ingenuity. Its continued survival into the modern age offers us a window into the past, allowing us to glimpse the resilience of life across millions of years. The ridged shell, the cloacal breathing, the bone-crushing jaws, and the ability to thrive in harsh seasonal cycles. All of these combine to make the alligator snapping turtle not only a fascinating subject for science, but also a reminder of the complexity and diversity of life. Each feature has a purpose, each adaptation a function, and together they form a creature that has endured long after many of its ancient relatives vanished. Conclusion: the alligator snapping turtle is more than just a predator of ponds and rivers. It is a living embodiment of survival, balance, and adaptation. From its voracious feeding habits to its months-long dormancy, from its unique respiratory system to its ecological role, it represents the intricate interplay of biology and environment. For those fortunate enough to observe one in the wild, caked in mud and armored like a relic from another era, it is a humbling reminder of nature's enduring brilliance. In the end, whether seen as the product of evolutionary trial and error, or as the work of a higher creative intelligence, the alligator snapping turtle stands as a testament to the resilience of life. Its existence enriches freshwater ecosystems, fascinates biologists, and challenges us to protect the fragile habitats that sustain such extraordinary creatures. Thank you for watching. If you would like to learn more about incredible animals, check out my channel.